This is Algebra 1's exam review for Chapter 3. So in Chapter 3, we really started diving into solving equations, showing checks. But right here in 3.1, we were just kind of starting to look at how these equations can be related to a real-world situation, and how can we represent that with tables and graphs. And then we got into actually solving them. So to start off here, David has $55 in the bank. He's adding $20 every week. Let B be his balance and W be the number of weeks. Write an equation for B in terms of W. So B is going to represent his total balance, or how much money he has. He's starting with 55, and then he's adding $20 per week. So every time the number of weeks changes, we can just plug it in. 5 weeks, 5 times 20. 10 weeks, 10 times 20, plus the original 55, and that'll give you his total balance. So we're going to make a table here, and this is telling you that our table should go from 0 to 10 in terms of the weeks. So we're going to go 0, 1, all the way up to 10. All right, so week 0 sounds a little funny to say it, but what that means is that's just where you're starting. No weeks have passed. So if you plugged in 0 and you multiplied by 20, it's just going to be 0 and go away. And so you're just going to be left with 55, which represents what he's starting with. So at week 0, that's how much money's in the bank, 55. That's what he has. After 1 week, you're going to add another 20. So we're at 75. Add another 20. We're at 95. So every week, just keep adding 20. Now in a table, we can just go 20, 20, 20, 20. Or you could actually plug the number in. Like when we get to 7, you could plug it in and do 7 times 20 plus 55. But since we're just going up one at a time, we're just going to keep adding 20. So 115, 135, 155, 175, 195, 215, 235, and 255. Okay, now we're going to take this information and we're going to put it onto the graph. Now, there's always a little bit of confusion about which variable to put on which side. When one of them is involving time and we want to see the other thing, especially money, changing over time, you want to put the time on the bottom. Okay, so this is going to be W, or weeks, and then this side is going to be B for balance. So our weeks, this would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. So we have 10 weeks. We can put all the information on the graph. And now we have to choose a number. Like if you counted by even tens, we're not going to get big enough to show all of this information. So we need to make sure that we're counting by something that gets us past 255 by the time we get to the top of the graph, so that we can actually show all of these points here on the graph. So I'm going to count by 25s because it's easy to count by and it'll get us up there pretty fast. So starting with 0, 25, 50, 75, 100. Hopefully this gets me there. 125, 150, 175, 200, 225, 250. So I actually came up just short, but close enough to 250 with the 255 that we'll be just fine here. All right, we're going to put these on the graph now. So at 0, we're going to go to 55. It's just going to be a little bit past the 50. 1's at 75, so perfect, right on the dot. 95, so just short of 100. And this should be a straight line because this is a steady increase. So it should produce a straight line that can help you with plotting these individual points that are in between. Number 3 is 115. So we're not going to go all the way to 125. Try and keep this in a nice straight line. 4 is at 135. Again, try and keep this in a straight line. 5 is 155, just above the 150. 6 is 175, right on the dot. 7 is 195, just short of 200. 8 is 215. Keep it in a straight line. And then 9 is 235 past 225. Again, trying to keep this in a straight line. And then this one would be just above the 250. Now, we're not going to connect this because this is not something where we can necessarily track what's happening in between week 1, week 2, week 3. We don't know when this $20 is being deposited. It's not like it's growing slowly in the bank where we could connect this and there's an actual amount of money between the 75 and the 95. Halfway through the week, he's not at like $80 and then $90. We don't know that. We're assuming they're just putting $20 in, so it jumps from 75 to 95. So we're not going to connect this. We don't think there's information that exists in between this. So we're going to keep it just like that. All right, so we made a table from the graph. When will David have $175 in the bank? And so we're going to say after 6 weeks. Explain how you found your answer. Now I used the table, but you also could use the graph. You'd go to 175, work your way over, and you would see that that is going to hit right there at 6 weeks. So table or graph can be used. All right, 3.2, we just started writing the equations. We weren't solving them yet. So just practice with writing, which we actually already did here in 3.1. So let's try another one. So Sarah bought 5 slices of pizza with a $20 bill, and she received $7.65 in change. So we can figure out how much the pizza cost. So we're going to write an equation to represent this. There's lots of different ways that you can actually write this same equation. So let's show a couple of them. So first of all, I like to think of it as you started with $20 and you spent money. So your $20 is going down, right? We're going to end up at $7.65. So we're taking a certain amount of money off, and that's going to be represented with a variable, but there's 5 slices. So we want to know how much each slice is worth based on this. So we're going to do 5p for pizza. I don't like to use s because it looks like a 5. And then once I take the cost of 5 slices of pizza off of 20, I know that I'm going to have $7.65 left over. Another way to write this would be to say that the cost of 5 slices plus the change of $7.65 has to come out to $20 total, and that works. And then you also could write it kind of opposite of this and say, if I have $20 and I take off the change from the 20, I'm left with the price of 5 pizzas. To me, that one makes the least amount of sense, although it's still correct and works, so I'm just going to leave these two. All right, so we're going to define the variable. P represents the cost of a slice of pizza. And then you'd actually have to go solve this here. So they're asking you what's the price, so we are going to go ahead and solve. Now, out of these two, I would say this one's actually more difficult to use. So we're always going to try and isolate that p and find out the cost. So we'd have to minus the 20 and then divide by -5. And a lot of people will, when they get rid of the 20, they'll drop off the negative on accident, and that can mess them up. So this one actually seems like it's a little bit easier to use. I'm just going to go ahead and take the 765 off. And that's pretty much the same thing we'd be doing here. We'd be doing 765 minus 20, which would get us a negative, but then we would divide by a -5. That would get us back to a positive. But over here we can keep things easy. So 20 minus 765 is 1235. And then you're going to divide by 5. And we get $2.47 per slice. Okay, 3.3 and 3.4, we start solving and checking these equations. Start off with some basic ones, and then we just ramped it up as we move through the chapter. So starting right here, we're always going to isolate x. So let's minus 430 from both sides. And now 5x is by itself. And I'm going to use my key here, so hopefully these numbers are right. And then we're going to divide by 5. X equals negative 23. All right, now we don't have a lot of room here, so we're going to kind of squeeze in these checks. So a reminder how to do a check. And these are nice, especially on a test or an exam, because you can plug your answer in and you'll know if it's right or wrong. And if it's not working, then that means you need to go fix it. Okay, so I'm going to rewrite the original, but when I get to X, I'm going to plug in my answer. So I'm going to plug in negative 23. First step would be to multiply here. So don't do anything else until you multiply. It's going to be a negative 115. And then you just go ahead and finish this side out. Remember, we're not moving on both sides of the equation and trying to eliminate. That's only when you have a variable and you're trying to isolate it. We don't have a variable anymore. It's all numbers. So solve the left side and basically find out, does it come out to 315? So when I go ahead and subtract this, it does come out to 315. So we're good. All right, same thing here with some decimals. So minus 3.25. So 1.06x is left over. I go ahead and subtract this and then divide. I'm going to go ahead and do the check up here. So rewrite the original 1.06. Instead of x, we're going to plug in 18.5. Okay, we go ahead and we multiply. And finish it out. Add these together, you get 22.86, which matches the other side. Check works. We know 18.5 is the correct answer. Okay, we now just throw it on the other side, so working the opposite direction to isolate x, no problem. Here's the one we're saving for last, so you're actually going to add 0.1 first. That's going to go away. Now we have 0.02x by itself. We'll divide by it in the next step. This comes out to 0.103. Divide by 0.02 to get rid of it. Now x is by itself. It's on the right side. That's totally fine. This comes out to 515. Real quick check. So 0.02 times 5.15. Squeeze this in. All right, we're going to go ahead and multiply. So this is going to stay here, a little smaller so I can fit it. Multiplying. And then subtracting, and sure enough, we're going to get this answer on both sides. All right. So those are your basic two-step equations, adding or subtracting, and then dividing. Then we talked about using the distributive property, solving equations. In the previous chapter, we simplified using the distributive property. Now we're going to use it in an equation. So right here, to solve this, we want to get them looking like these ones we just did, so we have to get rid of parentheses. So we're going to go ahead and distribute. Remember, this is a negative 3. When you multiply, the 5x just stays. So a negative times a positive is a negative 15. And here's where everybody messes up. Negative times a negative, you have to put a plus for a positive here. And that would be 6x. Combine like terms, you've got a 5x and you've got a 6x. That's going to be 11x minus 15. I put those together to get the 11. Okay, and now we're like a regular two-step, add 15 to both sides. It cancels here, and it cancels here as well. So we're going to put a 0. And then when we divide, the answer is just 0. And 0 is a number. A lot of times students think they've done something wrong, or they sometimes want to write no solution when they get 0 because we've done problems that do have no solution. Okay, but the answer is just 0. Now we're going to go ahead and check it. So we got 2 spots to plug into now, so that 0 is going to go in for x here. Minus 3 times, and then inside parentheses, 5 minus 2 times 0 equals negative 15. So we're going to have 0 minus 3 times, now 2 times 0 is going to be 0, so 5 minus 0 is just 5. The 0 can just go away. This is going to be negative 3 times 15, or some people would write this as 0 minus 3 times 5, 15. And just do it in one extra step, which is going to be negative 15, which works out. All right, and the next one, there actually isn't any distributing, just some combining like terms. So before you start trying to move things around, if you have things you can combine on the same side of the equal sign, so I have an x and an x both on the right side here, you do want to combine those first. So I got a 6x and a negative 18x. I'm going to put those together. That's negative 12x. I still have a plus 7. All right. Now I have to minus 7 to get rid of it because it's positive, leaving me negative 12x, negative 48. Divide. And a negative divided by a negative gives me a positive 4. Quick check. 2 places to put it in, so 6 times 4 plus 7 minus 18 times 4. So we're not doing anything with the left side. It's going to continue to be negative 41. We're going to see if the right side comes out to that. All right, so 6 times 4 is 24. 18 times 4 is 72. One step at a time. This plus this is 31. And then 31 minus 72 is negative 41. Check works. Good to go. Okay, and then we started looking at these with inequalities, less thans and greater than statements. And the biggest difference here was that there's 2 checks to show. The process is pretty much exactly the same though, except for the fact that if we divide by a negative, we have to flip the less than or the greater than sign. So the first one's all positives. We'll focus on the checks and the graph because it says solve, check, and graph. And remember, there's 2 checks to show. And then this one, we'll talk about what happens when there's a negative. So treat the less than like it's an equal sign, just trying to get x by itself. So x, no flip, we didn't deal with negatives, stays, x is greater than 6. Okay, if we're going to put that on a graph, here's 0, here's 6 up here. If this does not have an equal sign, it's going to be an open circle. Greater than, that would be the numbers going this direction, so you shade that direction like that. Again, 2 checks to show here. Check 1 is checking that this 6 is the proper endpoint, and so we actually rewrite this with an equal sign. 5x equals 30. We plug in our answer of 6 and make sure that it works. So we get 30 equals 30. It does work. So this means that 6 is the correct endpoint, but I got to make sure that my shading is going the right direction. So when I do check 2 here, I got to pick a number that's in the shaded area to make sure that my less than or my greater than is going the right way. So I'm going to pick 10. And when we do it this, we're testing the less than and the greater than. So we have to actually use it now, not the equal sign. So you plug in a number in the shaded region and make sure that this comes out to a true statement. So 5 times 10 is 50. This says 50 is greater than 30. That's true. So we do have this going in the right direction. If this came out to be untrue, then that means our answer has this facing the wrong way. And it's very easy for that to happen when we're dealing with negatives like we're going to see on the next one. So this check's very important. Don't automatically just say check. Sometimes this will come out to a wrong answer, and then the student just moves on. And that's kind of defeats the purpose of doing a check. If the check doesn't work, you don't just move on. You go back and you figure out where the mistake is. Okay, so this one, again, one little step is dividing. But since we're dividing by a negative, this is where we need to flip this. Okay, so now it faces this direction. And that comes out to negative 18. If I'm graphing this, here's 0, here's negative 18. It does have the equal sign, so my circle needs to be filled in. Negative 18 counts as part of the solution set, and this says x is greater than. 0 is bigger than negative 18, so are all the positive numbers, so we're shading in that direction. Now let's try our two checks. First check, we're using an equal sign, so rewrite the original with an equal sign. Plug in your answer. Make sure it does come out equal. Okay, two negatives will make a positive, and this does come out to 126. So again, that means our endpoint is correct. Now we got to check our shading. I think 0, since it's in our shaded region, is a great one to use. It's nice and easy in an equation. Some people fall in love with 0. You can't use 0 all the time. If we look back at the one we just did, 0 is not part of the solution set, right? It's not part of the shaded area, so you can't use it. For this one, though, it is. So let's go ahead and use 0. So you go back to the original, plug in a number that you want to use that's in the shaded region, not using this endpoint, a different number from the shaded region, and you leave this facing the way it was originally. Don't go to your answer flipped. Go to the way it was originally. Oh, and I was like, this isn't going to work because I added a negative for no reason. It's a positive 126. Okay, so this will work now. So I multiply and I get 0 is less than 126. That's true. So you can see I wrote negative 126, and in my head I was already thinking about what the answer was going to look like. 0 is less than a negative. That doesn't make sense. That would mean I was facing the wrong way. And I'm like, something's wrong here. And then sure enough, I caught my mistake. All right, and then the last two, same idea. We are just now going to have a longer problem to do. So this is a two-step. We're going to minus 5. Keep this facing the same way. Divide by 3. No flip, all positives here, so x, don't write equals, less than 3. If I'm graphing this, here's 0. 3 is above it. Open circle, there's no equal sign, and now it says less than. So I'm shading this way. Notice that 0 is in my shaded region, so when I get to check 2, 0 it would be perfectly fine to use. So check 1, rewrite the original with an equal sign, plug in your answer. 3 times 3 is 9. And then 14 equals 14. So 3 is our good endpoint. And then check 2. Rewriting the entire original and then plugging in a number that's in our solution set. I'm going to use 0. So 3 times 0 plus 5 needs to be less than 14. 0 plus 5 needs to be less than 14. Is 5 less than 14? Yes. So we are all good. All right, and then the very last one, we've got a lot to do here on the right side. Okay, combine some like terms. So negative 3x and negative 7. That's negative 10x. And then a 2 and a 203, both positive, just combine them, 205. So again, don't start moving things around to both sides, minusing on both sides. Some people will try and minus or add the positive 3x twice here, and that messes them up. You can only do that when one's on one side of the equation or the inequality and one's on the other. If you have a bunch of stuff on the same side of the equal sign or the inequality, you have to combine like terms first. That whole adding or subtracting to clear things out is when we're doing it on both sides of the dividing line, which is your equal sign or your inequality. Okay, so be careful there. Just combine like terms. Now this looks like a normal problem. We're just going to try and isolate that x. So we're going to minus 205. That goes away. 5 minus 205 is going to be negative 200. We're going to divide by negative 10. So we're going to have to flip here. We are dividing by a negative. So this flips the other way. Leave x where it's at. I go ahead and divide this. That's a positive 20. If this is confusing looking to you, you like the x on this side, you got to be consistent with this. Okay, so if I move the x, this actually has to flip the other way. These both say the same thing. If you like leaving it like that, you can. If you want to move x to the left side, that makes you happy, then make sure you do flip this once again so that it stays closed towards x. Okay, graphing it. Here's 0. 20 is going to be way up here. It's going to be an open circle. This says less than 20. We're going down. I noticed that 0 is in my solution set, so I can use it for check 2. Start with check 1. So we got to go all the way back to the original so that if we kind of only went halfway back, if we made a mistake from here to here, our check wouldn't catch it. So we got to go back to the original to catch any possible mistake. So for this one, we're going to put an equal sign and plug in our 20. So negative 3 times 20 plus 2 minus 7 times 20 plus 203. All right, so that's going to be negative 60 plus 2 minus 140 plus 203. And you can plug all of this into your calculator, and it does come out to 5. So we're good there. Check 2. Back to the original, using our less than sign, picking something in the solution. So we're going to use 0. So 5 is less than negative 3 times 0. 0. And again, 0 is a great number to use because it's just easy math here. This becomes 0 plus 2 minus 0 plus 203. So the zeros don't mean anything. You're basically just doing 2 plus 203, and that's 205. 5 is less than 205. It's true. We are good.